Hi, so my name is Johnny Nguyen, and my team members are Russ Johnson and Vincent Galachi, and we'll be presenting about MongoDB for web applications. So what is MongoDB? Well, it's an open source database, which means it's free for the general public. It uses NoSQL, so unlike the traditional relational databases with joins and queries, well, I guess this uses queries as well, but it doesn't use the relational database structure. Instead, it uses a document-oriented database, so it's an architecture of collections and documents, and you can think of the documents as comprised sets of key-value pairs, and they're the basic units of data, whereas the collections contain sets of those documents, sets of those data, and they function pretty much like tables, is what you'd recognize in the relational database structure. And as of July 2015, it's actually the fourth most popular DBMS, so for something that's open source, that's doing really well. So some history on MongoDB. On the top left and right, you'll see the main founders. So the top left is Kevin P. Ryan, and the top right is Dwight Merriman. And actually, Elliot Horowitz helped Dwight develop this back when they were under the company DoubleClick, which is now acquired by Google. And that was an internet advertising company. And they basically came to a chokehold where the performance wasn't doing well after it got to a certain amount of data. So they came up with, created MongoDB with the idea of supporting large amounts of data and being scalable. And it was commercialized in 2007, released to the open source in 2009, so that's when the general public could access it, and then renamed to MongoDB Incorporated in 2013. So some web applications that use MongoDB, obviously Google is a huge company, so they have a lot of web applications. But you can see Craigslist, Expedia, eBay, Verizon, eHarmony. These are huge names that are using MongoDB. And there's a lot more like New York Times or publishing places like Forbes as well. So not only is it open source, but big companies are actually using it as well. So why do they use MongoDB? Well, for the main part, it's scalable. That was the whole point of building MongoDB. It's able to write and read a lot of data. And then next is performance. So statistics say it can be up to 25 times faster than Cassandra, which is another type of database. And this is on a certain test, and that's an absurd amount. Considering Cassandra is a pretty popular software. And of course, it's open source. Obviously, those big names probably don't care if it's open source. Well, they probably do, but in more ways, it's really good for startup companies to be using MongoDB because it's free and it's really scalable. So they could start off as a startup, and if data gets too big, it's scalable, so it doesn't really matter, and in which case they'll protect the future. And it has a high write load capability. Well, what this means is MongoDB is basically created to write a lot of data, but the downside is you have to be careful with safety, because when it writes it, it's not very safe. And then load balancing, so it scales horizontally using sharding, and we'll talk about this a little later. But basically, load balancing is it runs over multiple servers instead of just one server. So this allows for backups as well. And of course, it supports large data sets. So the relational databases, you can kind of see performance hinder when it reaches the 5 to 10 gigabyte mark. Whereas MongoDB, you won't see that much performance drop, and that's a lot of it is due to that sharding, which we'll talk about later. So next will be Russ Johnson to talk more about the pros and cons of MongoDB.
Hi, I'm Russ Johnson, and I'm going to be presenting now. I'm going to compare MongoDB to relational databases like SQL. So let's get into it. Relational databases, also known as Relational Database Management Systems, or SQL, come in several flavors. Commercially, there's Oracle, Microsoft SQL, and then there's some open source variations, MySQL, Postgres. It was first developed in the 70s, so it's pretty mature by now. It's described more as structured and rigid, using the tables, columns, and rows to store data. There's relationships that are defined between the tables using primary and foreign keys. And it's transactional in nature, so you can have complex transactions that involve updating multiple tables. Okay, so that's that. And then if we look at MongoDB, that's a document-oriented database, also known as NoSQL. First released in 2009. It's open source, and I think there's also a commercial side to it as well, but there is an open source community that works on it. It's more object-oriented, semi-structured compared to SQL, and it uses JSON, or JavaScript object notation, JSON-like documents to store the data. And in MongoDB, they call it BSON. And so on the right, there's a few documents there that kind of show some example structures, and you'll notice the, it kind of looks like JavaScript inside there. So those are some of the attributes for those documents. And MongoDB is highly scalable. One of the big features is its scalability. We'll talk a little more about that. The schemas are also flexible and dynamic. And so what that means is documents within a collection can have different attributes. So in this example, the beer, maybe one of those beers has an attribute for picture, and there could be a nested structure under that picture attribute where there's more curly brackets, and you could list out several different pictures that are associated to that beer. And it accepts all different types of data formats in a document. So it's very flexible, and the documents don't all have to have the same attributes within a collection. They can be changed and updated and added on the fly, which is great for agile web development. All right, so if we compare and contrast a little bit between the relational data model and the document data model, on the left you can see relational data models, highly structured table organization with rigidly defined data formats and record structure. And then you have the document model, which is a collection of complex documents with arbitrary and nested data formats and varying record formats. So then below that you can kind of see how some of the terms coincide with each other. So in SQL you have a row or a record. Well, that's known in MongoDB as a document. Table is known as a collection in MongoDB. Primary key is the ID, so on and so forth. So the next slide here, we're going to talk about MongoDB and relational database management systems and how they plot out on a graph here, where we're looking at scalability and performance and depth of functionality. So you can see MongoDB is strong in both of those areas. It's flexible, the dynamic schema that we talked about, and very scalable. So it gives it a lot of functionality, and it's very scalable, which is good because a lot of the implementations of MongoDB are more for big data type of applications. Relational database management systems, they're very rich in functionality. They've been around a long time, very mature, but they're less scalable. Not to say that they aren't scalable, but their scalability tends to come at a higher cost as they have to scale up, whereas MongoDB can scale out. So let's talk about that scalability a little bit more. When you scale up, it's costly. It's a lot more costly than to scale out. Scaling up involves, basically beefing up your server and turning it into a supercomputer to continually add, resources to it to scale to meet your application's demands with your database system. MongoDB, you can scale out and just keep adding more standard servers, and that tends to be a lot more cost effective. So that horizontal scalability that I was referring to is one of the big features of MongoDB, and it implements that through sharding and auto sharding in particular, which is a nice feature. So that's automatic. That allows saving data across many servers. So it's a distributed architecture out of the box. Running MongoDB over multiple servers is going to improve your performance. allows for load balancing and data duplication, kind of giving you some peace of mind there with automatic kind of backups of your data, and like we talked about, it's cost effective to do that rather than building a supercomputer. So there's a lot of features, good things with MongoDB. Let's look at maybe a few of the disadvantages. So transactional support's one. Operations on a single document are always atomic, but if you want to try to run a transaction that involves multiple documents, there's no such thing in MongoDB. You'd have to manually verify your code and verify it and commit it. They're not atomic like they are in a relational database like SQL. Relational integrity is also a little disadvantage compared to SQL. The relationships are managed at the application layer rather than the database management system, and sometimes the complex relationships can be difficult to manage in this. Another drawback is familiarity. So there's a learning curve to this. It's a new technology. It's going to use a different language, not SQL, that most people are used to when working with databases. Since it's newer, there's less documentation out there and smaller support community compared to the SQL. So also concurrency issues is another drawback. Write operations create a lock on the entire database. And lastly, joins. There are no joins in the document-oriented database system. If this is needed, it has to be done using multiple queries, and then the results have to be joined manually within your code. So there's some give and take. It's not all good, but there are a lot of pros, and then there's some cons to weigh when considering MongoDB. So I'm going to pass it on to Vince, who's going to talk about the next section in our presentation.
Hi, Vince here, and I'm going to quickly talk about some supported languages, general commands, and how to utilize MongoDB in a PHP web application. MongoDB supports many languages, C++, PHP, Ruby, Java, Python, and many more. For a full list of its supported languages, there's a link at the bottom of the slide. Today we're going to focus on PHP. MongoDB offers free drivers and PHP libraries. Today I'll show you how to connect to an instance of MongoDB, choose a database, choose a collection, read, add, remove, and delete data, and then finally how to display it in the browser. So once you've downloaded and installed the PHP driver and library, you'll want to create a database connection object. First, you declare a variable and then call the Mongo client. And the 2 forward slashes, the server name, and then finally the port number, which is optional. The default port number is 27017. Most of the places where I've read said that for HTTP protocols, add 1000 to the default port number. Next, to connect to an actual instance of a database, you'll use the variable and then call the specific database that you would like. Now that you're connected to the database, you want to connect to a collection. Again, using the variable for the database, call the collection. First, I want to briefly talk about how collections are stored in the database. Each document is stored in a BSON format, or binary structured object notation. It is an extended form of JSON. It is basically a data interchange format and consists of key and value pairs. It can contain multiple data types such as string, integers, even objects such as images or other defined objects. Here are two simple examples of what a document in a collection may look like. It consists of an object ID, the key name, and the key phone. The second example illustrates a nested array, where the key name has a key first and last with two values. Now let's look at some simple commands that will interact with the MongoDB. For searching a collection, we'll use the keyword find. This example will return all documents in the collection. Additionally, parameters can be used within the parentheses on the find by just inserting the key and the value that you wish to search for. The PHP driver also supports ranges and logical operators. To add a document to the collection, we'll use the keyword insert. In this example, we will insert name and phone. Again, the object ID will be automatically generated. To delete a record, we'll use the keyword delete1. In this example, we will delete the first record where the name is John Doe and the phone is 555-555-9876. To delete multiple records, simply change the delete1 keyword to delete many, and then insert the key and value that you wish to search for. For updating a document in a collection, we will use the keyword update1. With this structure, we will look for the first instance with this phone number, and then set the next phone number to 456-789-0123 in this case. Again, to be able to update more than one document, change update1 to update many. To display results, first search a collection and store them in a variable. In this case, I used results. The MongoDB PHP driver now supports iteration of the BSON format. So, simply loop through the results as a result. In this case, we're using an unordered list, and then echo the result with the field that you specify. And it's that easy. So now you know the basic commands for creating a database connection object, connecting to an instance of MongoDB server, a specific Mongo database instance, and a collection within the database. You know how to query the database, read, update, delete, and then finally display the results. The results can be inserted into a paragraph, a header, a table, anywhere you want it to go. Just remember to download the driver and the PHP library.